Hi everybody. Today we're looking at the converse of the Pythagorean theorem. In the previous section we looked at right triangles and saw that they had a unique relationship, and that was a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. This time we're testing to see if given lengths of a triangle are right or if the triangle is acute or obtuse. So the Pythagorean theorem converse states, if the square of the longest side of a triangle is equal to the sum of the squares of the other sides, then the triangle is a right triangle. Okay, so that should make sense. That's just stating the converse of what we already know. But now, what about for acute triangles? So if the sum of the squares of the two shorter sides in a triangle is greater than the square of the longest side, then the triangle is acute. So if the two shorter sides, the sum of those squared is greater than the larger side squared, it's acute. So the converse theorem for obtuse states if the sum of the squares of the two shorter sides in a triangle is less than the square of the longest side, then the triangle is obtuse. So let's see if we can state this a little bit more simply. If I have a squared plus b squared equals c squared, then the triangle is a right triangle. If a squared plus b squared is greater than c squared, then the triangle is an acute triangle. If a squared plus b squared is less than c squared, then the triangle is an obtuse triangle. So let's take a look at example 1. Determine if the triangles below are right triangles. So in this orange triangle here, I know all three sides. I know that 8 root 5 is larger than root 16 or 8, so I have to use that as c. And 16 and 8 I have to substitute for a and b. So let's find what 16 squared plus 8 squared are. Added together is 320. Okay, so 320 equals 8 root 5 squared. So that's the same as saying 8 root 5 times 8 root 5. 8 times 8 is 64. And root 5 times root 5 is root 25, which is also just 5. So 64 times 5 is, let's multiply this out. And we get 320. Okay, so we get 320 equals 320. So a squared plus b squared equals c squared in this case. So yes, this is a right triangle. Now in part B, I've got 3 given sides, and I'm going to substitute the 2 shorter ones into a and b, and the longer one, 26, in for c. And I get 1060 equals 676. So clearly a squared plus b squared is greater than c squared, so this has to be acute. And that's it. So example 2, now we want to test to see if they're acute, right, or obtuse. So for part A, I'm going to set it up as a squared plus b squared, and I'll put a box here. I don't know what it is relative to c squared. So I want to find out which the largest side is here. So 3 root 5 is about 6.7. So that means I have to use 8 for c. So 6 squared plus 3 root 5 squared equals 8. Well, I don't know what it is actually, so I'm going to put a box. 8 squared. So now square these numbers, add them up. And so 9 times 5 is 45. I can write that. So 36 plus 45, what was 64? 81 is greater than 64. So it's got to be acute. If a squared plus b squared is greater than c squared, it's got to be acute. So for part B, we're going to follow the same pattern here. We're going to substitute the two shorter lengths in for a and b. 15 squared plus 14 squared is 421. And 21 squared, 441. It's close, but not quite. 441 is greater than 421. So that means a squared plus b squared is less than c squared. So what does that mean? Obtuse. It's an obtuse triangle. So for part C, let's call 14a, we'll call 48b, and 50c. I'm going to substitute it into a squared plus b squared. I'll get rid of the equal sign there. Put a box. I don't know what it is relative to c squared. So 50 squared is 250, or 2500. So 14 squared plus 48 squared is 2500. So these are equal. So a squared plus b squared equals c squared. Well, it's right. And that's it. So we're just using the Pythagorean theorem to test if it's acute, if it's obtuse, or if it's a right triangle.